Hello and good morning. So the hard stuff is over. When it comes to revolving a solid of revolution around an axis, you've done the grunt work. But now we get to show you a little bit of variety here. So we're going to take a solid of revolution, but instead of revolving this thing about the x or y axis, we're going to involve it around some other vertical or horizontal line. So here's an example. Find the volume of solid of revolution generated when a finite region S that lies between y equals x squared and y equals x is revolved about the line y equals -1. There's the new stuff. We're not revolving it around a y-axis or an x-axis. It's about the line y equals 1. So take a look at the picture. The red graph represents x squared. The blue represents y equals x. And this purple line down here is what we're going to be revolving, this region S, which is blue. We're going to be revolving that blue region about the purple line. So if you imagine this thing coming up off the paper at you, wrapping around a full 360, I think we can all agree that there's going to be a hollowed out area. Think in your mind's eye what that hollowed out area might look like. And you'll probably come up with something like this. Okay, now what you're looking at here, this section right here is y equals x squared. This section right here is y equals x. This is the solid of revolution S right here, just that little area. So when we wrap this thing around, this little megaphone looking shape is all hollowed out. Okay, and then here's our center of revolution, which is the purple line right there. All right, so how do we set this integral up? Well, it's really not that hard. We have to find a short radius and a long radius. But now instead of the radius coming off of the x-axis, the radius is now coming off the line y equals 1. So the radius is going to have a different length to it. We have to find the length of that radius. The longer radius, which is going to be the longer distance from that purple line, is going to, the longer radius, r of x, is simply going to be the function x, because this is y equals x, minus a -1. All right, that's how we find the distance of this blue line. It's x, the blue function, minus a -1, which becomes x plus 1. That's our longer radius. The shorter radius, which is the red radius here, again, starts at y equals -1 and goes all the way up to y equals x squared. So the distance is going to be x squared minus a -1, or we say x squared plus 1. Once you get those radii, then setting up the integral is a piece of cake. Keep in mind that the disk, or the washer I should say, has a width of dx, right? It's a washer that has a width of dx. So because it's in dx, because the width is dx, we're finding the volume, or we're going to be calculating this integral in terms of x. So just the volume of the washer itself is going to be the volume of the outer disk minus the volume of the inner disk. That's how you get the volume of the washer. So pi r squared is the area of a circle. So it's pi. Well, we've already learned this. You can factor out the pi and you can factor out the delta x. So it's going to be pi times the larger radius squared minus the smaller radius squared dx. That's just the volume of the washer, but we're doing infinitely many washers over what interval? Over what x interval? From 0 to 1. All right, so when I plug all this stuff in, and then I go ahead and integrate from 0 to 1, I can bring the pi, because that's a constant, bring the pi to the outside. I get the definite integral from 0 to 1 of the large radius, x plus 1 squared, minus the small radius, x squared plus 1 squared, dx. And you could do that. We're fully confident that you can do this on your calculator at this point in time. So when you do this on your calculator, you're not going to have an answer in terms of pi. I mean, you could, but you don't have to. And on this next set of exercises, you don't have to calculate the integral. As a matter of fact, on the answer key, you're going to find that the integral is not calculated. All you have to do is just set up the volume integral. All right, go ahead and get to work.